Yeah, everyone is able to hear me. Yeah, there was some update about the mic. Okay. See, so last thing we did was this. Hope everyone has gone through the notes. It's integration one. Chalo, cams on everyone. Let's start off. Great. Let's go ahead with a few more problems. Okay. We got a building here of height h. So you're throwing a particle with speed u horizontally. So this is horizontal projection. So this will go and land somewhere here. And let's say you projected a particle with same speed u, but this time upward with an angle theta. So it'll go and again land somewhere here. You're projecting u with a speed, same speed u, but you're projecting it downward. If you see, we did something like this in the 1D motion, up, leaving at rest and everything. So find range and time of flight for all the three cases. And speed when they reach the ground. There, let's get them. This is the standard model. When you throw from building, these are the three possibilities you have, right? Either you throw horizontally or up or down. That's it. These are all the cases that you can cover. How do we do this? Okay, let me show you one in case you're confused how to go ahead. So let's take the first case when you're throwing horizontally. Like I keep saying always, get your data. First of all, get your data right. So let the initial point be always the origin. You're projecting with you. You go and land somewhere on the ground. So the point where you're landing on the ground, if you look at the coordinates, this point coordinate will be 0, minus h. Only the y coordinate will change. This point will be r, minus h. So you're leaving from origin and you're landing at r, minus h. And what are the speeds? Horizontal speed ux is equal to 0. Vertical speed uy is equal to 0. Ux is u and uy is 0. That's all the information you have. Next thing. We are using the equation sy is equal to, remember, whenever you want to find time, Only the vertical direction will matter. Horizontal will never affect your time. What is Sy? The negative displacement. So minus H. So signs are important. You forgot a sign, everything will go for a toss. Uy is 0 because you're throwing horizontally. Minus half G T1 square. If you notice this is the same answer as the problem where you dropped a particle from rest. Because when you drop a particle, Uy is 0. Here also Uy is 0. So for time, what matters is only the vertical component. This is your time of flight. And be careful. Don't remember this for everything. This is valid only for horizontal projection. What about range? Sx is equal to ux t plus half ax t square. Sx will be your range, the horizontal distance, ux is u, t will be your time of flight t1, and this guy would be 0 because there is no ax. If you look at gravity, we have ay is minus g and ax is 0. So u into root over 2h by g. That's your range. All clear with this? Speed, we will talk about it. Actually, what you could have done, we could have done the second case directly and we could put theta 0, theta minus theta, and that would give you A and C case. You can always do that, but okay, I just wanted to show you. Got the idea? I'll give you one more minute. Get the remaining two parts. There, so put your initial point as origin, get your initial data, and see which equation fits. And if you still say we are just playing with the same three equations, v is u plus at, s is ut plus half at square, and v square minus u square is 2s. Try. You got a minute more. Yeah, it's okay. Find the relation between the three times, Anish. The three times, right? T1, T2, T3 will have a relation. Just like we had one in that vertical motion, here also you'll have a relation. That you should definitely remember. Those are the kind of questions they ask in, bits and sometimes mains and CET. So there, if you start deriving everything, you'll be running out of time. Okay, let's go ahead. Yeah, speed is right through. Okay, let's see the B part. Now, this is important, see how I'm putting okay, get the data, get this thing. It might feel silly and all. The thing, you need to understand when you're in the exam hall, you're under pressure, you have to perform in 3 hours. When you don't do things systematically, right, you won't get speed there. In the exam, most people say, we'll go to the exam, you will think, frankly speaking, it is bullshit. If you have not seen something similar before, or if you have, don't do things systematically, in an exam like mains, if there are 25 questions, you should have seen at least 20, 22 questions beforehand. Somewhere, something similar. If you go to the exam and start deriving and everything from scratch, you will run out of time. The way this mains exam is going on from last 6 years, physics and chemistry, you are supposed to finish all the paper in 90 minutes. Max paper comes really tough. And that's what will decide if you're planning to score 180 plus, without max, it's not going to happen. Again, based on last 5-6 years. So you should be very systematic with things. So don't try to skip steps when you're learning. When you're learning, keep all the steps. In the exam, I'll tell you, you can automatically skip steps because you got so used to doing it, properly, detail. When you're doing a problem, right, you can actually see those steps in the air. I don't know whether you ever experienced it. That happens when you do it very systematically. One simple thing. Let's say you're doing a question and you're not getting it. You tried once, you're not getting it. Second time, you're not getting it. You know what most people do? They're doing it here. They'll scribble it here only. Second time. Third time also, they'll scribble it here only. Stop doing that. Take a fresh paper and do it properly. If you're not getting it, I mean, there is something there. So yeah, same steps. So I'm going to use for time of flight Sy is equal to uyt plus half a yt square. This is minus h. Uy is vertical. Up is positive, down is negative. U sine theta 2 minus half g sine theta t2 square. G t2 square. You get a quadratic. Minus h is equal to 0. From here, you can get t2, which is u sine theta, plus root over u square sine square theta plus 2gh by g. What is range? Sx is equal to ux t plus half ax t square. If you see, I'm just playing with that one equation. So Sx becomes your range, ux is u cos theta, and time of flight is t2. Substitute there, you'll get your answer. And the same thing if you do for C part, the only difference would be this time you're throwing it down. This is theta. The vertical component would be u sine theta. The equations will look same. The only difference would be this would be minus sign. This would be plus. This would be T3 and T3. So there, I just want to show you, like, see, all the three are exactly the same. The only difference is the speed is changing. This is T3, T3. This is T3. This is minus. This is T3. You get the answer. All clear with this? Great. Next thing. Now, for the speed, what will I do? We'll just do the B part and you will see something interesting there. So when you project it with U and theta, this is your U cos theta and this is your U sine theta. So when you land on the ground, if I do Vy square is equal to Uy square plus 2Ay Sy, Uy is U square sine square theta. Ay is minus g, it is pointing down. Displacement is also minus h. And we know Vx square is Ux square plus 2Axsy. We know this term is 0. So Vx square is U square cos square theta. So what is the speed? Speed is nothing but root over, you have to take both the components, Vx square plus Vy square. That means when this particle is landing on the ground, this speed will have two components, a horizontal component, which is Vx, the vertical component, which is Vy, and that will result in a speed V. And if you do the square u square will go off, you'll end up with u square plus 2gh. If you observe, this answer is independent of theta. Meaning it doesn't matter with what angle you throw, you're going to fall with the same speed as long as your initial speed is same. And there is a much better way to do this. Remember this. This belongs to a chapter later on, energy, but I'm sure you can handle this much. Look at this. You're throwing the particle here with speed u. You're going and falling on the ground with speed v, and this was your height h. Law of conservation of energy. In school, I'm sure you studied this. Loss in potential energy is equal to gain in kinetic energy. Energy does not depend on the angle. What is the loss in potential energy? You are falling a height h, so mgh. What is gain in kinetic energy? Half mv square minus half mu square. From here, you get v is equal to root over u square plus 2gh. Can you see? One step, you get the answer. By using energy, you can get the answer much faster. And the answer is independent of theta. That means in all the three cases, the particle is going to fall at the same place. Fall with the same speed. Are you clear with this? So this is a neat trick using energy. So it belongs to a chapter going ahead, but yeah. And if you look at the 3 times, this is a very good result you need to remember. T1 square is equal to T2 into T3. We derived it for the vertical thing. It's valid here also. So T1 is the thing when thrown horizontally. Do remember the result. All clear with the steps? Everyone clear what we did? We found the initial data, final, kept it in the equations and we finished it. So that's how you do these questions. And these are 3 possibilities. You can't throw in any other way on a building. Clear. Let's do a question like this. I'll give you numbers. Let's see so that you get used to it. We got a building here of height 160 meters. We projected a particle with u is equal to 20 meters per second at an angle of 60 degrees. So this thing goes here and lands on the ground. Let's call this A part. This angle is alpha. Find alpha. B part of the question, we got a building here. Someone threw a particle with 20 meters per second at an angle of 60 degrees. This particle goes and falls on the building and hits at 30 degrees. 2 different questions. Find the height of the building. 2 different questions. In the first thing I gave you the height, I asked you alpha. In the second case, I gave you alpha and I'm asking you height h. So this is thrown from down. It goes and hits the top of the building at 30. Get them. These are pretty good means level questions. Out of 25, you will get half of the questions like this only. Not too tough and not something like you can just put a formula and get an answer. So you have to think a little. Advanced questions would be like the thing we did last time, the gravity changing with x coordinate. That would be an advanced question currently at your level. When you're in 12th, even that would be an advanced easy question. As you keep growing strong, questions actually become easy. Get them both. Get me the answers. I'll give you 1 minute more for the first one. Then I'll show you. And keep trying. And inverse root 35. Interesting. Can you give me an answer in terms of cos? And inverse root 35 might be right. I'm not sure. Give me in terms of cos, meaning you can convert this into cos. How much would this be? 35, 1. Yeah, I think you're right. You're right, Prasha. Let's see the first one. Now, when you get these kind of questions, right, the idea is this. Look at the question. What is given? I gave you initial speed. I gave you initial angle. I'm asking you final angle. Now, alpha red comes only in 2 equations. One with the time equation. If you remember, that was tan alpha is equal to u sine theta minus gt by u cos theta, or u cos theta is equal to v cos alpha, isn't it? So one thing I can do, I can find the time of flight. I can substitute there. I'll get the answer. Nothing wrong. Or I can use the other equation, but for that, I need to find the speed. So one way to handle this is we will find the speed using conservation of energy. So this is speed V. So loss in potential energy is gain in kinetic energy. You're losing potential energy mg 160. The gain in kinetic energy is half mv square minus half mu square. Will cancel on both the sides. We end up with v square is equal to u square. U square is 400 plus 2, g is 10, and this is 1600. How much is this? 16 by 6 on 60, sorry. That's 3,600. Means we get v is equal to 60 meters per second. Then we can use the result. U cos theta is equal to p cos alpha. U is 20, cos 60 is half. This is 60 and this is cos alpha. Cos alpha is 1 by 6. So yeah, that's the thing about these questions. You can use energy and get them fast. Now using that logic, can you get the second one also? I'll give you a minute. I think that's right, Prasha. So if you can somehow find the final speed, everything was taken care of. Yeah, one way to do is you get the time and do it. That works. Might be a little lengthy. Okay, let's see. How is u cos theta? Seriously? That is what you're asking. Please revise the notes. How can you ask that? There, this was the result we derived, isn't it? The horizontal velocity always remains same. Yeah, happens. We keep forgetting sometimes. Same story here. So initially it is 20. Finally, let the speed be v here. Now here you're losing kinetic energy. So I'll say loss in kinetic energy is gain in kinetic potential energy. Because the speed is decreasing here. So this is half m 20 square minus half m v square is equal to mgh. But how do I find v? I know u cos theta is equal to v cos alpha. I think that's one of the biggest clue, whenever someone gives you the final angle, indirectly they're telling you the velocity. This is 20 cos 60 is half, and this is v, and this is root 3 by 2. So v is equal to 10 by root 3. Substitute there. This is 200. This is 50 by 3 is equal to 10h. That will cancel there. That is 16. I messed up something here.
Sir, is it 10 by root 3 or 20 by root 3?
Yeah, 20 by root 3. Then this would be also 200. Then that would be 40 by 3 meters. Yeah. So whenever they ask about the final angle and they're talking about speeds and heights, preferably, right, try to use this, the energy part instead of time. Time के साथ answer आएगा, but it does become a little lengthy. Clear with this. So the idea comes like this. There are only two formulas, one with the time, one with the alpha. That if it doesn't click, then you will struggle. You will get the answer. It might take 3 minutes if you try to with the whole time thing in the exam. Time matters a lot. If you do your physics paper fast enough, if you can save little time, that will help for other subjects. Or maybe you can do the tough question, which will take a little more time. All clear with this?
So can we just take in the first equation
Mm-hmm.
of B, like you have written half m20 squared. So
Yeah,
can,
that is your initial speed, right?
yeah, but uh,
It is the loss in
okay,
kinetic
never
energy,
mind. I
right?
understood. I understood.
You're losing, na? The initial must be more than the
Yes,
final.
sir. I thought you have to take the y component or something, but
No, no, speed,
uh,
na? Half mu square u is the total speed. So,
yes, sir. Yes, sir. Got it.
yeah. Let's see the next one. So we have a particle projected with speed u and theta. So we got some weird planet here at a distance of r by 2, that is half of your range, where r is equal to u square sine 2 theta by g. So the gravity on the left-hand side is g, and the gravity on the right-hand side is 2g. Something happened. The gravity suddenly became doubled once you cross that line. So then you won't fall at the same place, isn't it? You will fall somewhere here. Find x. In terms of r, option should be something like that. X is equal to r by 2, root 2 r by root 2, r by 2 root 2, so r by root 3, options like that. So give me answer in terms of r. The gravity becomes 2g after particle crosses h max. After x is equal to r by 2 as shown. Yeah, I shouldn't say x. After r by 2 as shown, find x. Let's get this. And this is another thing you have to be careful. They will do all kind of stunts like, something change, this thing change. The whole problem will look something weird. So what is step one when you see something weird? Don't panic. Take it step by step, understand what is happening, see what you can do. Convert it into something which you already know. And if you still panic, think of like this. Oh, if I'm panicking, then most of the country is panicking. That is good, right? So let me just calm down and get it right so that others will mess up. Did you figure out even how to start? Like how do you can convert this? That's the important thing. In case you still didn't figure it out, I'll help you out with this thing. Say, you're saying when you reach r by 2, the gravity becomes double. So at this point, what is the velocity? U cos theta, isn't it? So this whole question has become like, you know what? There is a building here of height h max. Someone is throwing a particle with u cos theta, and the gravity on this side is 2g. Now, doesn't this problem become like a building problem? There, that's what you should think. Don't see the double gravity and get scared. You should ask yourself, okay, h max mein I know the speed, I know the height, so gravity became 2g. This is looking like a building problem. Yeah. So that's a very important ability. Like, whatever you don't know, if you can take that and if you can connect it to something which you know, suddenly you start getting ideas. And that's what we mean by thinking. Thinking doesn't mean you sit there and keep staring at the problem and suddenly you get enlightened like Lord Buddha and you know how to do. That's never going to happen, right? You always enter the unknown from known. So, okay, this is looking like what? Yeah, that is how we humans always learn or we interpret things from what we know. Give me answer in terms of R, na? I told you, right? So I think you guys got it, but maybe I'm not sure. Nah, nee, Prashad, that is wrong. Karthik, wrong. It's not really that bad of an answer. Just check your calculations. Maybe you're goofing up there. Concept-wise, you guys understood. You just have to treat it as a building, but this time the gravity is 2g. Yeah, that looks right, Anish. Right, Prisha. So let's see. So the idea is this. When you projected this, and when you reach the highest point there, your speed becomes u cos theta. This we know. At the maximum height, the gravity is Vy is 0, and this guy is your h max. So you can say this whole equation has become like this. We got a building whose height is h max, and you're projecting a particle with u cos theta. And indirectly, I'm asking you gravity is 2g. I'm asking you find the range. For a horizontal projectile, we know the time of flight. Time of flight is root over 2 times h by gravity. But gravity became, I'll just write g nu, okay? So, but the gravity became g. So 2 h is u square sine square theta by 2g. And the new gravity is also 2g. So that's u sine theta. 2g comes out and root is there, root 2g. The range will be the horizontal velocity u cos theta into time of flight, which is your x. So this is u square sine theta cos theta by root 2g, multiply and divide by 2. This will become u square sine 2 theta by 2 root 2g. But you know u square sine 2 theta by g is r. So this is r by 2 root 2. Check. All clear with this? Let's say same question, similar model. Any doubts on this? So now it looks like a building problem, isn't it? So that gravity became double is just to scare you. If you actually see behind it, it's a building problem in disguise. And that is how most of the problems are there. So if you can figure out the disguise, right, your problem becomes easy. So don't panic. Always see and say, oh, this is looking like what? That is the question you need to ask yourself. The more you ask yourself that question, right, at some point, without asking that question, your brain will actually figure it out. You see that and you know what is happening. Your thinking happens so fast, you think it happened instantaneously. It happens with our teachers mostly because like that's what we have been doing almost for 2 decades. So when I see a question, I know what to do and I don't, it feels like I didn't think only. Now you will reach that state. So keep working and keep working on that. Frankly speaking, I was much faster when I was writing my advanced exam than when I became a teacher. I actually became slower after becoming a teacher because I have to focus more on explaining things properly, right? When you're a student, it doesn't matter. Getting the answer was the only priority. So same stuff. So we projected a particle with this. The gravity is g, and this time the gravity became horizontal. We have really a weird planet. The gravity just changed its direction. The gravity on right side of r by 2 becomes minus g I cap. Draw the trajectory and find the time of flight. Meaning, how will the path go? Describe the motion and find the time of flight. Actually, if I ask you time of flight, you have to draw the trajectory. Let's get this. Yeah, Danish, you have one answer. Try. I'll give you one moment. This is a pretty neat question, It's not difficult. I said Danish, right? Correct. So this is a pretty neat question. It's like looks a little weird and all, but once you figure it, it'll take less than a minute to solve. So let's see if you guys figure it out. Yeah, right, Prisha, right, Karthik. See, again, same story. If you look at this particle at the h max, the speed becomes u cos theta. So this is how it looks. So when you projected the particle with speed u, you go till here. And when you reach here, the speed becomes u cos theta. But now the gravity suddenly became horizontal. Now just look at the particle ka perspective, okay? Just turn the page 90 degrees and see. It will feel, now say u cos theta and g are opposite to each other, isn't it? This looks like a 1D motion. This particle will go straight. It will stop somewhere here. It will take a turn and come back. But the moment it comes back, it will again come back with u cos theta. The gravity has suddenly became g again. So it will again fly and come back to the same point. Is that making sense? At this point, it becomes v0 there. If you just turn the page 90 degrees, doesn't this part of the motion look like a vertical projectile? Particle is thrown up with u cos theta and the gravity is g. It will go up and come down. But when it comes back and crosses the line, gravity will again change direction, so it will fall down. So if you look at this whole motion, it looks like this part, which is u sine theta by g, time of ascent, plus the green one, which is a 1D motion, which goes and comes back. This is 2u cos theta by g, because it looks like a projectile. You're going just with u cos theta. And while coming back again, the time of ascent and descent are same. This would be again u sine theta by g. So this thing comes back to the same point of projection. So the time of flight will be 2u sine theta by g plus 2u cos theta by g. Is that making sense, everyone?
Can you explain
Yeah.
its trajectory again?
This red part you understood?
Yes.
Now, once you cross the h max, how is the velocity? Horizontal. And how is the gravity on the right side? That is also horizontal. If your velocity and gravity are anti-parallel, how will the motion be? It will go in a straight line, right? So just turn the page 90 degrees. So what do you see? If you turn the page 90 degrees, it looks like this, isn't it? Particle is going up with u cos theta. The gravity is g downward. Then what do you think will happen? As it goes, it will slow down, slow down, slow down, stop.
Stop it.
Then it will take a turn, come back, come back, come back. It will come back with u cos theta. But once you come back with u cos theta, now the left side is again gravity down. It feels like there is a building here and you're going back again.
Okay.
Since you came with u cos theta and you go back with u cos theta, we can say by symmetry, you will go and land at the same point. Is that story clear, everyone? Did you see? Once you realize that, it barely takes a minute to solve. But once you see gravity changing direction and all, it gets scary. So it's just a fear factor. Now, let's do something on this. I mean, what if we will not solve this thing, but what if, let's say you're projecting with u and theta. And let's say this time the gravity, right? It changes before this only, r by 3. The gravity here is g and the gravity here is g this way. Can you draw the trajectory? Just draw the trajectory. How will the path look like? Assume there is no ground, okay? You can go down also. Same thing, let's say here the gravity is g and here the gravity is g, but this time it's 2r by 3. So this is not exactly at h max, so there will be a vertical component. approximately, just draw the trajectory. I'll give you a minute, then I'll draw and show you, see whether you got the same thing. I know you can't send this answer, so think about it and draw. And once I show you, let's see whether you got the same thing. Approximately, no need to draw it exactly like, oh, this is how it looks. These are the kind of questions they'll ask you. They'll give you 4 options and you have to choose the right one. Draw the trajectory. Trajectory matlab the shape of the path. Show you. Try another 30-40 seconds. Okay, let's see. Let's see. You just have to be careful. See, one thing I'll tell you. Whatever trajectories you get will be all parabolas only, isn't it? We have done this before. Like, if your velocity is at an angle to the gravity, you'll be always in a parabola. Different parabolas. So the first part of the motion, you will go in a parabola, but you won't complete a parabola here. Look at the velocities. This would be your u cos theta. I'll just write ux, and this will be uy. So now just turn the page 90 degrees. If you turn the page 90 degrees, how will this look like? It will look like this is your velocity v, and this is your gravity g, isn't it? So this itself will go on another parabola like this. This will actually be a full parabola there. And it will come out here with a speed v again. You will come out here with speed v. Now, once you come out with a speed v, the gravity again became down. So this guy will look like, a projectile again from a building. So this will fly like this and fall down somewhere here. How are you getting the path? The green part is clear, how it is. Just rotate your head 90 degrees and you will see. Doesn't that look like a projectile? If you rotate your head 90 degrees, then this becomes horizontal, isn't it? I hope you got the same thing. Any doubts on that, please ask him. What about this guy? So let's take this as G. So this would go like this. Now here, see, you crossed 2r/3. If you crossed 2r/3 means you're already going down. So if you're already going down, so the velocity will be v like this. And now your gravity is g this way. So you will actually go like this. Like I said, assume there is no ground. So once you come from here, you'll come back with v. Once you come back with v, now it feels like a building problem where you're throwing down and you will fall like this. This would be the gravity. I hope you can see how the parabolas are coming. Parabolas are simply getting shifted. Is this clear, everyone? So they can play like this, meaning they can ask you a question like this. They will say the particle is projected with u and theta. At a distance x, the gravity changes. So we want the particle to go here, go like this, And when it goes here, it flies and comes back to the same point of projection. Then find x. You're getting? You can play like that and make a question. It just becomes a little lengthy, but yeah, it can be done. So we don't know. They can play around, they can do a lot of changes and all, but it gives you an idea how to handle this stuff. Any doubts on this? Clear? Let's see one more standard question. Yeah, these are little non-standard, matlab. Not really that out of the world, but yeah. We got a tall building. So the tall building ka meaning is you can safely assume the particles don't hit the ground so fast. So we have one particle projected with speed u, we have one particle projected with speed 2u. Let's call them particle A and particle B. So A will go this way and B will go this way. You can take the initial point as origin. And we are projected horizontally with ui cap and minus 2u j cap, I cap. So one is left and one is right. First question. Find the time when the velocity vectors are perpendicular. So velocity of A must become perpendicular to velocity of B. B, the displacement vectors are perpendicular. This is a standard mains level question. It has come before. And these kind of questions repeat a lot. They might ask you any one. Mains questions do repeat a lot. Sometimes they repeat at such a hopeless level. The question which came in the session 1 comes in session 2. So that is the reason we tell people like, session 1 में जो papers होते हैं वापस resolve करो. Even this year, I think there was one session where we got 2 questions directly from session 2. So because you think about it logically, right? The question paper, they have a big question bank and a computer is selecting questions from the same question bank every time. And it has certain instructions, isn't it? Rotation says do questions do, kinematics says do questions do. So when you have a restriction like that, it is bound to do something like that. That's what I keep saying. Standard models should be thorough. When your standard models are thorough, then when you do higher level questions, it saves you time. That's the thing, that's what I'd keep telling you. If you're solving 100 questions, you should solve at least 20 easy questions, 40 to 60 moderate questions. I would say at least 50 moderate questions and maybe 30 tough questions. If you try to do all 100 tough questions, you will go mad and irritated. You'll never gain speed. Let's get these two. Okay. Right. Everyone should get this. Okay, let's see. That looks like Karthik. Dhruv, think that looks right. Prisha, you got it both right. Let's see. Man, when you saw the question, right, what is the first thing that came into your mind? If I read this question, right, first thing that comes into mind, I'll forget about what is the question. Vectors are perpendicular. This is based on dot product. That is the first thing that should hit your mind before anything else. And once you get that, and then you know, okay, if the vectors are perpendicular, means I need to find the vectors, right? So let's find the vectors. So this is your point A. This is your velocity ux. Is u, ui is 0. This is your ux is minus 2u and ui is 0. Perfect. So for A, the velocity vector VA bar is nothing but Vx I cap. Remember, it's a full velocity vector and Vy j cap. Vx is 0 and Vy is nothing but 0. Sorry, Vx is ui cap plus 0 minus gt j cap. So this is ui cap minus gt j cap. This is your velocity vector VA bar. What about the displacement vector? Same thing. SA bar is equal to UA bar T plus half A bar T square. So I can write it in terms of X and Y coordinate. RA bar is XI plus YJ. What is X coordinate? U into TI cap. What is Y coordinate? U sine theta minus half GT square, but that is 0 UI half GT square J cap. UTI cap minus half GT square J cap. This is your RA bar. Same thing if you do for B. We get VB bar. The only difference is you're going backward. So minus 2 UI cap minus GT J cap. The vertical components will be same for both of them. Similarly, if you do RB bar, you're going backward. So this will be minus 2 UTI cap. The vertical will be same, half GT square. See, both of them have same vertical velocity. So vertically, everything will be same. Horizontally will change. So this is RA and RB. This is VA and VB. Great. First question. VA bar is perpendicular to VA bar. So VA bar dot VB bar, these are two different questions, is equal to 0. Do the dot product. You end up with what? U square T minus you have to do the red one. So maybe I'll use the red color. So it will be easy to figure it out. First question, VA bar dot VB bar is 0. So UI cap minus 2I cap minus 2U square plus G square T square. So we get T is equal to root 2 U by G. This is the answer. This is the thing when the velocities become 0. In case you're still wondering, what do you mean by velocity is 0? So when it is falling here, at some point, this will be the velocity. At some point, this will be the velocity. If you extend the vectors, the velocity vector, they're perpendicular. What is the displacement vector? Displacement vector meaning you take this point and this point, join the initial and the final, join initial and the final. If you extend these two, they will be perpendicular. I hope you're getting the meaning of displacement and velocity vectors. Displacement vector is simply final minus initial. If you take initial as origin, then the coordinates is the displacement. The second one, displacement bar is RA bar dot RB bar. Same story, you can do this. This would be minus 2U square T square plus 1 by 4 G square T power 4. This would be 2 root 2 U by G. You get the double of this. Please check. All clear with this? So there, if you see, it is getting that I cap, J cap vectors and the things and just getting a dot product there. Standard question. No, not that easy, matlab, you still have to know your standard results and put everything there. Any doubts on this? Clear? Take a break. Come back by 9:42. We'll continue from here. Any doubts so far? Chalo, come back by 9:42. So let's get this thing. So we have a stone which is projected 20 meters per second from a building, and there is a window on the right side, 20 meters far and 20 meters down. Find theta if the stone falls into the window. Let's get this. Can everyone? I hope the question was clear. You're throwing a stone with 20 meters per second. There is a window at a 20 meters far and 20 meters down. Everything is 20. Find theta. We have done something like this before, throwing a stone into the window, and the idea is still the same. You should always ask what is being given indirectly. You'll get a good answer in tan theta, right? Okay, let's see. Basically, what they're giving you is the coordinates. Anytime, whenever they say it is falling there, it is hitting here, indirectly they're giving the coordinates. What is this coordinate? 0, comma 0. What is this coordinates? 20, comma minus 20. So we use the equation of trajectory. Your answer might not be wrong. If you just convert it into tan, you should get the same thing. And you'll get two answers actually. X is equal to tan x tan theta minus g square. This was your equation of trajectory. Y coordinate is minus 20. X coordinate is 20. Tan theta. G is 10 and X is 20 square. And this is 2 and 20 square. 6 cos square theta is sec square theta. 20 goes so 5 minus 4. 4 tan theta. Sec square theta is 1 plus tan square theta. There you get a quadratic in tan. Tan square theta minus 4 tan theta minus 3 is equal to 0. So we get tan theta is 4 plus or minus b square. 16 plus 12 by 2. 2 plus or minus root 7. Why did we get two answers? We got two answers because we thought there was only one answer, but there are actually two angles. Tan theta 1 is 2 plus root 7. This is the positive angle. Tan theta 2 is 2 minus root 7 is a negative angle, meaning we didn't realize it, but Max is saying, boss, there is a second way to throw this. If you throw this particle down with a negative angle, even then you can go into a window. Because the question was simply, you're throwing it from the top of a building. You didn't say whether you're throwing up or throwing down. So you have two possible answers. This would be your negative angle theta 2. So there are two ways you can throw from that spot with 20 meters per second, and both the possibilities can fall into the window. Clear with this? That's the meaning of a negative angle. You're throwing it downward. Negative angle indicates it's throwing down. All clear with this? Let's see. One more. If you see, right, we did so many questions, but end of the day, it all comes to the three equations only. Particle is projected with u and theta. We have our gravity. Now, there is also an horizontal acceleration. So till now, we are taking ax is 0. Now you can't anymore. So let's say there is a wind which is blowing, and you get a horizontal acceleration because of the wind. Find range, h max, time of flight. Find theta if stone goes back to the point of projection. So we want the stone to come back to the point of projection. If the wind is blowing really hard, there is a possibility you come back to the same place. It happens for a very specific theta. Draw the trajectory for different values of A. Let's say A is negative, A is left-hand side, A is right-hand side, A is very large, A is very small. So roughly, how will the pictures look like? Draw the trajectory for different values of A. Because A is a variable, right? It can be positive or negative. Let's get the first one. There, this is the First time we are seeing where you have both ax and ay. Till now, ax was always 0. Now, be careful. Even in this problem, if you noticed, when you're going on the right-hand side, there's only one acceleration, isn't it? There was never a horizontal thing there. So here you have both horizontal and the vertical component. Again, don't get scared and think like, oh, what the hell is happening? Like, go back to the basics. What are the basics? If you remember how we started the whole story, this is what we said. Everything that happens in the vertical is taken care by u sine theta. Everything that happens in horizontal is taken care by ux. And when we did these derivations, if you see the formula, we wrote this ax was always 0. We used to take that as 0. We will not take it as 0 anymore. That's the only difference. Everything else will be same. Try. Get the first part. I'll give you a minute or two. The C part is the thing which I'm more interested in. But yeah, I know you can't show it to me, but think about it. Let's give it a try. Everyone should try. It's okay not to get an answer, but should try. Okay. Nere Karthik. You might be right also. You might be right actually. But no, you're wrong. Remember, A is backward, right? There'll be a minus sign. Be careful with the directions. A is not forward. A is not supporting your motion. It is actually opposing the horizontal thing. Here, A is negative. The most easiest ones are Hmax and time of flight. Yeah. That is the first thing you should say without even solving the question. So the reason is this. Anything that happens in the vertical direction depends only on the gravity G and independent of horizontal acceleration. That's your first statement. You can get that without doing anything. Horizontal acceleration does not affect the motion in the vertical direction. Right? And therefore, if you remember Hmax ka formula, what is Hmax? Uy square by 2ay. This is the reason in the beginning I wrote it in this form, everything in uy and ay. What is uy? U square sine square theta. What is ay? G. Didn't change. Nothing dependent on the horizontal. What is time of flight? 2u vertical by a vertical. Again, nothing changed. So the time of flight will remain same. What you want to find the range? Sx is equal to uxt plus half ax t square. So the horizontal distance range, ux will be u cos theta. This will be your time of flight. Acceleration is on the left-hand side, so minus a. If it was right, I would have taken plus a. And this is the time of flight square. Substitute here. This would be u square sine 2 theta by g. This was your regular range. Minus half a 4u square sine square theta by g. I will leave it to you here. You can simplify that. So, this would be 2a u square sine square theta by g. That's your answer. Now, if it comes back to the same position, range must be 0. So if you put range is equal to 0, you end up with sine 2 theta must be equal to 2 sine square theta. Sine theta is 2 sine theta. There is an a by g also. 2 sine theta cos theta. We get tan theta is g by a. For this particular angle, you are going to come back to the same point. Clear with this? Now, if you try to draw the trajectories, this is what will happen. Now, if you notice something here, my range is wrong. There is a g square. Okay. So now, if you notice something here, look at h max and time of flight. Independent of acceleration, you get the same h max. That means if I try to draw the trajectories, this is how it looks, everyone. First, let's put a ceiling here. So this is your h max. Means no matter whatever is the acceleration, you cannot cross this black line. So first, let's draw a normal one. So let's say you're throwing with u theta. You will go normally. You will graze this and you will fall this. So this is the scenario when a is 0, normal acceleration. There is no horizontal acceleration. Maybe I can draw in red. So this would be a regular problem. Let's say you give some acceleration in the forward direction. This time you will go forward, but remember you will again just graze this black line. You will not cross this. This is the case where AX is positive. So AX is greater than 0, meaning your A is, the wind is blowing forward. Right? Now, if you start putting it backward, let's say your A is negative. You will start going like this, and then you'll come back like this. This is the case when the wind is blowing backward and A is negative. If your wind is blowing really hard, there is a possibility you will actually go back like this and you'll fall backward. This is a case where the wind is highly negative, matlab A is backward. A big number, let's say minus 20, minus 30 or something like that. So the wind is blowing really hard backward. Now in all this, there is one special case, where if you throw with, if the wind blows at a certain angle, you will just go straight, touch the black line and come back. This is the case where your tan theta is equal to A by G. Or you can say if the wind blows with A is equal to G tan theta backward, negative x-axis, you actually go in a straight line and you come back. Is that orange line making sense? I'll talk about that orange line more. So the few things here, all trajectories, right, will go in a straight line, meaning we'll always touch that h max and come back. So it doesn't matter how the wind blows, you have to touch that black line and come back. So they can ask questions like this actually, they can give a question like this. They will say, two particles are projected with u1 theta 1, u2 theta 2. This particle goes like this and this particle goes like this. Both the particles are same h max. Then they can ask you, which is bigger, u1 is greater than u2, time of flight is greater, range is greater. They can ask options like that. All of these things have same h max and time of flight. Right? And if you see the trajectories, right, all are parabolas except for that one. All trajectories are parabolas. These are still parabolas. They're simply parabolas which are tilted. All trajectories are parabolas except for A is equal to G tan theta, which is a straight line. That's it. Either you can get a line or a parabola. You cannot get any other shape. Now, when I say it comes back, what people think, they generally think of like this. They think you projected with U. This will go like this and it will come back like this. This is a general perception. लगता है ऐसा, मतलब some people think like this. Now, in real life, it might happen because of air resistance. And this is not possible. This will never happen. This is not a parabola. This is not a straight line. So if you just want to find the acceleration for a straight line, right, there's a much easier way to do. Look at this logic. When you're projecting with U and theta, the particle comes back to the same point if your acceleration is opposite to it. So if this is acceleration and if this is gravity, the resultant of these two accelerations will be your net acceleration. Right? And this angle will be theta. So from here we can clearly get tan theta is equal to G by A. I think I wrote wrong here. Tan theta is G by A. My mistake. G cot theta. So this is the scenario where you go in a straight line and you come back in a straight line. If your net acceleration and U bar are opposite, the particle goes in 1D motion. If you remember, this was one of the things we wrote in a projectile. A bar and U bar should be always at an angle, not parallel or anti-parallel. Are you clear with this? Whenever I say it comes back, this will never happen like this. It will come back only if you go in a line and come back in a line. The U bar and A net are opposite to each other. So the particle will think it's a 1D motion. It goes up and comes down. So if the question was find the angle when it comes back to the initial position, you need not do all this story, isn't it? You can directly go with that logic. U bar and A bar are opposite. You can just draw this one picture and you'll get the angle directly. Is this clear, everyone? This is how you do when the wind is blowing. You just make Ax is equal to minus A or plus A, depending on which way it is blowing, and then yeah, everything else will fall in place. Any doubts on this? Dave, Ananya, Anish, Dhruv, Manav, Yukti. Clear? Tanmay? Rohit? Clear? Now, this is an important problem because this will form the basis for the next part, projectile on an inclined. If you understood what we did right now, this should be manageable. They are kind of same. Projectile on an inclined plane. You'll be able to handle all type of projectile motions now. I think you should start doing projectile. Don't delay it anymore. The workload will suddenly explode. Like you should spend some time and get these things done. So what is an incline here? So let's say we have a wedge kind of thing. This is an incline structure here. So this angle is alpha. Alpha is called the angle of inclination. This is the angle made by the wedge with the horizontal. This is angle of inclination. And let's say you projected a particle with a U and a theta. This thing goes and falls somewhere here. Theta is the angle of projection with the incline. So be careful. Till now we used to take theta with the horizontal. Here we are treating with the incline. Angle of projection with respect to incline. So then here what will become the range? this green line which I'm writing here, that would be the range. So this is the range on the incline. So if someone throws a particle on an incline and they ask you, boss, where it is going to land, this is what we call as range. And what is the idea here? Again, same story. We are not doing anything new. Go back to the basics. Go back to the introduction, see what we said. We study this motion by resolving the motion along two perpendicular directions. Did I ever say it should be up and down, right, left? We never said that. We always said divide the motion in any two directions. They should be perpendicular, isn't it? And if you see the basis for this also, so this is the technique we are going to use. Since you can divide in any direction, let's choose your x and y axis in a very convenient way. So this is my incline. This was your alpha. So we are going to choose the incline as an x-axis. So we'll choose this as x-axis. And we will choose perpendicular to this is y-axis. Because how do you know how is x and y looking like? You can choose anything you want. And then what is the idea? When you throw the particle with u and theta, this component will become your ux, which is u cos theta, which looks like the normal one. This component is your uy, which is u sin theta. And this also looks like the normal one. But now the gravity g, which is down, will also split. Now, how to get the components for that? Look at this. A little geometry here. So this is alpha. This was your gravity g. If this is alpha, this angle will be also alpha because this is 90 minus alpha. So this component will be g sine alpha and g cos alpha. This is how you can divide the gravity there. That means we can split the gravity in this direction, which is ax minus g cos alpha because it is opposite to x-axis. Ay, I'll do one thing, I'll just put it plus for now. So we can say this is g cos alpha. And this is your g sine alpha and g cos alpha. See what we did. We have split the problem into horizontal and vertical. Now look at how the whole problem looks. So just take this incline and rotate it a little. Now this problem looks like there is a particle, someone threw it with u and theta. The horizontal component is u cos theta. The vertical component is u sine theta. In the vertical direction, we have ay, which is g cos alpha. And in the horizontal direction, we have ax, which is backward g sine alpha. Now, doesn't this problem kind of look like this problem now? Are you getting it? The only difference is the g car will have two components. So the horizontal component looks like A, the vertical component looks like G. Other than the values, they look similar to this thing. So this is similar to the horizontal wind. Similar to, meaning it gives you the same vibes as that problem. And this is similar to gravity. And that's what I said. If you understood that, this things you will understand. Similar to G. Is this making sense, everyone? And once you get this, how will the equations change? So this was your AX and this was your AY. Same story. What is time of flight? 2 u vertical by a vertical. This is the reason if you see from the beginning, I always wrote it in this form. What is u vertical? 2u sine theta. What is a vertical? This guy, g cos alpha. See, we got the time of flight. What do you want to find? Range, Sx is equal to ux t plus half ax t square. Sx will give you a range. Ux is u cos theta. T is the time of flight, which is 2u sine theta by g cos alpha. What is ax? Just be careful. So your ax is opposite to u cos theta. So we are taking that as negative. So that would be plus half minus g sine alpha. To u sine theta. Yeah, it looks big and all, but if numbers are given, you understood how to do this thing. Square. Simplify this will give you range. Is the idea clear, everyone? Now there is something more here. If you want to find a maximum range, now unlike the horizontal motion there, this would be not that straightforward. We have to do maximum minima. Dr by d theta is equal to 0. We'll not do that. I'll give you the final result for that. You can differentiate and check it out. But is this process clear what we did? You know how to find time of flight. Then you have to take s is equal to ut plus half at square. Everything is same. The only new thing you learned is that you have to divide the gravity into two parts. Once you do that, this becomes a wind problem. Is that theme clear, everyone? And for the maximum range, these things, you better remember them. You will not be able to derive them in the exam. It takes time. So for the maximum range on the incline, we have two cases here. Case one, let's say you throw it from the bottom. You're throwing with u, theta, and alpha. And when this thing goes and falls here, the maximum range when you throw it from bottom is given by u square by g 1 plus sine alpha. You will get this by doing maximum minima. And the angle of projection theta must be pi by 4 plus minus theta minus alpha by 2. So when you throw from the down, this is the maximum range and the angle of projection is pi by 4 minus alpha by 2. Alpha is the incline. Case 2, if you're throwing it from top, so unlike the horizontal thing, here it depends how you're throwing. Here the maximum range will be u square by g 1 minus sine alpha. And your theta becomes pi by 4 plus alpha by 2. Alpha will be given and theta they're asking. If I put alpha is equal to 0, this becomes a horizontal incline, then you get theta is equal to 45. How do you get this? You get this by differentiating this function equal to 0, you'll get the theta ka value. Yeah, you will get it, but you can check it out. All clear with the steps. This is how you handle when you're throwing on inclines. Hey, don't worry too much. We'll do a few problems on this, you'll get the hang of it. But everyone got the process? Let's do one or two problems. That should make things more clear. Let's do with numbers. So we have a particle here. This is 30 degrees. You're projecting here also with 30 degrees. And your speed is 20 meters per second. Find range. Okay, we have an answer, but I don't know whether it is right. Anyone else got something? Step one, choose your x and y. Generally, this is the idea. You're throwing this way, right? So take this as x, and that is y. ux uy, divide gravity also, ax ay, put it in the formulas, time of flight, and sx is equal to uxt plus half axt square. I know it's easy for me to say, but try, take a minute, give it a try. It's fine if you get stuck and if you don't get it, but if you do that and next question, then you'll get it. Solve. Okay, Prisha got a different answer from Anish. One of you is definitely wrong. Anyone else got something? You have two different answers. Okay, Anish says it is wrong. Then anyone else? One more answer. I'll show you another 30 seconds. Should type your answers. Like if you're doing, I hope everyone is trying to type here to the co-host. Don't type it to the host. That is where I'm writing. I can't see you. Yukti, you got double the answer of Prisha. So Anish got 0. That's an interesting answer, Anish. Anish, I'll tell you one thing. Logically, socho. When you'll get 0, if you throw it straight up, you'll go and come down, right? That is the only time you'll get 0, isn't it? And for that, this total angle should be 90 degrees. So let's see how to do this. That's what I keep telling you, It's okay to get wrong answers, but you should know when it is a blunder. Look at the steps. So this angle was 30. So I will choose this guy as my x-axis. This is my y-axis. You're projecting with 20 and this is 30. So this component is ux, which is 20 cos 30. Uy is 20 sine 30. Gravity, this guy would be g cos alpha. This would be g sine alpha. I would strongly suggest you can remember this stuff. Cos alpha is also 30 here, luckily. So g sine 30. So those components you should know. That will keep coming a lot. So you should know, yeah, sine alpha, cos alpha is hoga, correct? This was your alpha. So you're done. So what is time of flight? Time of flight doesn't care about anything. It is 2u vertical by a vertical. What is u vertical? 220 sine 30. G vertical is 10 cos 30. That's tan 30. 4 by root 3. That's your time of flight. What is the range? Sx is equal to ux time of flight plus half ax time of flight square. Ux is 20 cos 30, 20 root 3 by 2. Time of flight is 4 by root 3. Acceleration is minus. How do I know it is minus? Look at this. Ux is going in next direction. This is going opposite. If both are in the same direction, keep it a plus sign. So this would be minus g sine 30, 10 into half, and time of flight square is 16 by 3. I don't think you'll get a root anywhere here. So the root 3 goes off. This is 40 minus 40 by 3. 80 by 3, Prisha, you're right. Anyone else got this? Maybe some of you added a plus, I guess, there. So be careful with the signs. Yeah. Right, Dhruv. Right, Karthik. Anish. Right, Anish. Are we clear with this? Understood how we did this? Let's see one more so that you get used to it. This time, let's throw it from the top. Let's say this angle is 37 degrees. You're throwing horizontally with u is equal to 5 meter per second. This is also 37 degrees. This thing comes and falls somewhere here. Find range on the incline. Let's get this. This is just numbers again. Like choose your x and y axis properly, resolve the velocities, time of flight is 2uy by ay, and the stuff. Get them. 75. 75 by 16. That looks more better than 75. 75 looks just too big. Okay. Yeah, 75 by 16. We have multiple answers. Okay, let's see. So first thing, how do you choose your x and y axis? So I will choose, whatever direction it is going down, I'll choose that as x. So there is no restriction, like you can take any direction as up and down. So this is your y. Resolve them into components, and this guy would be ux, which is 5 cos 37. Hope everyone remembers what is cos 37 and everything. Cos 37 is 4 by 5. So this is 4. This is 5 sine 37. That is a 3. This is uy. So gravity ka component, this guy would be g cos 37. G sine 37. Sine 37 is 3 by 5. This is 6 and this is 8. Time of flight 2 uy by ay. Uy is 3. This is 8. So that's 3 by 4 seconds. That's your time of flight there. The range would be ux. That's 4. Time of flight is 3 by 4. Plus half ax is 6. Now this time it is plus because it's in the direction of x-axis. Time of flight is 3 by 4 ka square. Yeah, do this, you'll get 75 by 16. That's what most of you got. Must be right. So the only difference between this and the previous one, there it is a minus, here it is a plus. Other than that, everything looks the same. All clear with this. So I hope you can see, right? Incline, when you see them, don't think like, oh, incline. Think of that wind problem. Once you do that, then you'll feel like, oh, we are just dividing A into components. That's the only new thing. Everything else looks fine. Any doubts on this? So let's see the next one, which is easy and difficult. Depends on whether you know the result. So we have an incline here. This is angle alpha. Same incline alpha. You threw a particle here with speed u. This thing went and fell here. The range was r1. You threw the particle up with same speed u. This time it came and fell somewhere here. The range was r2, which was also the maximum range. So you threw a particle up the incline and down the incline with some angle such that you got maximum range. And it is given in the question if r2 by r1 is 3:1, then find angle of inclination. So when you throw with the same speed up the incline, down the incline, you get different ranges, the different maximum ranges, and that ratio is 3:1. Then what is alpha? I'm sure you don't remember the result, so just copy it down. That's what I said. If you know the result, the question is very easy. If you don't know the result, then you have to derive this. So when you're throwing up, 1 plus sine alpha here. When you're throwing down, 1 minus sine alpha. That you can remember. Obviously, when you throw down, you should get more range. So denominator must be smaller. But you need to remember that form though. Now get it. It's pretty straightforward. Right, Anish. Okay, let's see. Yeah, 30 is an answer. So straightforward. So when you're throwing it, R1 is U square by G, 1 plus sine alpha. This is your R1 max, and this is your R2 max. Is U square by G, 1 minus sine alpha. When you divide R2 by R1, you get 1 minus sine 1 plus sine alpha by 1 minus sine alpha, and you're saying this is 3 is to 1. So 1 plus sine alpha is 3 minus 3 sine alpha. Yeah, the sine alpha is half and alpha is 30 degrees. Clear with this? So that it looks pretty easy because you know the formulas. Now you don't remember that, then you're gone. Clear with this? Let's see one last one. If you got this, I think then your inclines are good enough. So this is alpha. You are throwing a particle with speed u at an angle theta. This particle flies and hits the incline perpendicular to the surface. So when this is hitting the incline, it will hit perpendicular to it. Find the relation between u and theta and alpha. If the particle collides perpendicular to the incline, options would be something like tan theta is equal to cos alpha, sin theta is equal to cot alpha. So that something would be like that. There'll be 4 options. They're not asking for any perfect numbers, but there'll be some relation like that, like perpendicular to the incline. This does not happen every time. It happens for a very specific relation. Only then you will hit perpendicularly. Like you could have hit this like this. You can hit like this. You can even hit like this, isn't it? Even this is possible. If you throw hard enough, it can hit at an angle like that. Look, that looks right. Anyone else? Another 30, 40 seconds. Karthik. Nere Karthik, you got really weird one. You had a good one in terms of tan. In both, you'll get in tan or cot. Let's see. Story is always the same. Since you're throwing along the incline, choose your X and Y axis based on that. This is your X axis. This is your Y axis. This is your UX, which is U cos theta. This is your UY, which is U sin theta. And now you're telling me this guy is going here and hitting the incline perpendicularly. Means when you hit the incline perpendicularly, look at this, what is happening. Your final velocity Vx has become 0. That is the meaning of it. There is some velocity Vy. There is no velocity in this direction when you're hitting the incline. So indirectly it is given Vx is 0. Since hits perpendicularly, there is no component along x. That is the data you have to pick from that statement. Component along x is 0. Yeah, once you got that, you're done. So indirectly, they're giving you V final. What is time of flight? 2uy by ay. This story is still the same, which is 2u sin theta by g cos alpha. Yeah, let me write that thing also. So this is your ax, g sin alpha, which is actually 9 minus sin, and this is ay, which is g cos alpha. And now it is given in the question, Vx is equal to ux plus axt. Vx is 0, ux is u cos theta, ax is g cos alpha. Time of flight is 2u sin theta, this is g sin alpha by cos alpha. We get 2 tan theta. Yeah, simplify this, you get tan theta, tan alpha is equal to half. You can write in terms of cot also, but yeah. Check, there should be a 2. Is this clear, everyone? I'm not asking for a range here. So the main idea is when you're hitting the incline, Vx became 0. That means I know time, I know Vx. So yeah, that should be the relation there. Any doubts on this? Clear? So that's a bit of an incline. So next class when we catch, we'll continue from here. We will do little more on inclines. We're almost done with projectile. I think maybe we'll take first half of the class. We'll wrap up with projectile and then we'll start off with relative motion. So we're left with 2 more things in the motion, relative motion and graphs. Both are important. So that should go for another 2 weeks, I guess. So we'll wrap up the chapter with that. We have done almost 53 questions, everyone. So please start doing it. This is a good amount of questions. So if you see the notes itself has a lot of collection of questions. So start solving them, right? And please start doing a material. Don't delay it anymore, right? You can do my booklet. You can do HCVC. This is something I keep telling you. Don't run behind too many materials. Choose 2 materials and do them thoroughly. Whatever the materials, choose them and do them thoroughly. Make sure to finish off them by next year when we finish off the portion. So that should be the target. Every 2 weeks or 2 months, right? Some of your friends will come and say, oh, that book is great. Oh, this book is great. Just ignore them. Focus on one book. You keep jumping every book, every month, you will do nothing. So